at the beginning of last year, we decided to go on a bit of a journey and understand the topic deeper when it comes to adopting cloud and whether actually using cloud platforms can help businesses become more sustainable. So we published this ebook that talks about exactly that and what is the messaging that the cloud providers put out there from a sustainability perspective. And then the other thing that we thought about is actually how would businesses continue to optimize their cloud platform and manage from a sustainability perspective the use of resources. And we thought that there's a strong link between that and running costs down, and that's where the FinOps practice area comes in. So FinOps is basically a practice that, when adopted by businesses, helps drive costs of using cloud further down, and therefore would align itself well with becoming more sustainable in general. And the reason why we thought that, because in general, according to research that has been put out there by 451 Research and other providers, that adopting cloud, running your business application workloads on a cloud platform like AWS or Microsoft Azure or GCP will help drive your carbon footprint down by 80%, just in general, because you're running more optimally. And we thought that BJSS, because we have quite a lot of experience in helping clients adopt cloud native architectures, is to help support cloud businesses on that migration journey with our migration engagement model that we have published on our website. Also, recently, we've put out another blog post to talk about FinOps more specifically, and how by using FinOps can help drive your cloud cost down, and through that optimization, driving your carbon footprint down. But essentially, today, what we're going to be focusing on is what does the cloud providers actually claim to be their sustainability agenda? So what do they say around sustainability as a topic? Also, we will share with you some of the concepts that you need to know and bear in mind when considering the sustainability agenda and finding out from the market and the industry how to become more sustainable. And then we're going to go into some architectural decisions and choices that you could be making using the cloud platform capability in that regard, and sharing a use case at the end. But before we start, just to engage the people that are attending, we have a poll. So the first question that would love for you to answer: is cloud currently being viewed by your organization as a top priority when it comes to like emission reduction? Is it an opportunity that you see as prevalent? Okay, yeah, thanks for all the responses. So, great. So the vast majority, 69% of you, think of it in such a regard that it's an opportunity to help reduce your emissions when it comes to IT and technology specifically. So that's great. You're in the right place. So here are the results. So what do the cloud providers actually claim in this regard? So to start with, AWS, they have published what they regard as their shared responsibility model, whereby they look after their global infrastructure and make sure that they invest heavily in how it's run and operated, and we're going to cover some of that later. But essentially, they look after things such as servers, cooling, the use of water, how do they manage the waste across all of their global data centers, and then provide you as a consumer or a customer the ability to make choices around your code efficiency or data storage, your encryption choices, and even compute choices to run your workloads as effectively as possible. And in general, AWS and Amazon as a whole, which is the company that owns AWS, they are aiming to run 100% of their operations on renewable energy by 2025. And Amazon as a whole, as a company, they're looking to become net zero carbon by 2040. And last year at reInvent, they published the AWS Customer Footprint Tool, which is basically a carbon calculator that shows you as a consumer of AWS how much emissions your workloads are emitting into the environment. And the tool, it's still quite high level, i.e. it doesn't provide the granular details that you would expect from such a tool, but at least it gives some information around carbon emissions across different regions or by service. And reInvent is upon us next week in Vegas. And I am assuming that there will be a load of launches and new services in that space. So watch that space. Microsoft, on the other hand, they have Microsoft Cloud for Sustainability, which is, again, a suite of products and tools that allows you to ingest a load of data from the value chain that supplies your business or provides services to your business, as well as the way that you run your IT, and then helps you produce reports using models that they've created around emissions that your business are emitting into the environment. And actually, this will be the topic of the use case that we're going to cover later. And Microsoft, in general, in our view, are quite mature in that space, quite advanced, and they've published a study back in 2018 to show that the use of the Azure cloud platform will allow businesses to run at 93% more energy efficiency, but also reduce their carbon emissions by 98%. And in general, they've also published a timeline, historic timeline of their investment in this space. So dating back to 2009, where they started with their first carbon emission reduction goal. But they also are talking about looking forward, how they want to invest heavily in not just reducing carbon emissions, but the use of raw materials, creating a circular economy and reducing waste out of the data centers, and other things that we're going to dive into in a minute. Google as well have quite a lot of credentials when it comes to sustainability in this space, and they publish on their website that 78% of their waste is delivered from landfills. 100% of their cloud regions run on renewable energy, and actually their cloud carbon footprint tool, in our view, is quite detailed and very granular. So in their console, when you're launching a particular instance or a particular service, it shows you how much, whether this runs from green energy or not. In general, to summarize, all three cloud providers claim to have very good credentials when it comes to sustainability, and they actually do. So we're going to dive into that in a minute. So on the next step, there are some key concepts that we think are important to know in this space, and we've learned this over the past year when researching for the ebook. So the first concept to know that there are three different types of emissions. So there is what is known as scope 1, which is direct emissions from the running of your business day to day. There is what is known as scope 2, and these are indirect emissions, essentially carbon emissions that are released into the environment because of the energy that you consume as a business. And a lot of the reporting that we see from the cloud providers, whether it's AWS or Microsoft or Google, tend to be very accurate when it comes to scope 1 and scope 2 emissions. Scope 3, however, is a bit harder because scope 3 involves third parties and the entire value chain in terms of upstream and downstream. So everything that delivers value into your business, from logistics to suppliers to manufacturers and their emissions, employees, employee travel, and so forth, to handling everything after the service has been delivered, whether it's waste management, everything to do with the downstream of that value chain. And actually, what is known is 70% of that, or actually 60% of it, tends to fall under scope 3. 70% of the emissions or carbon emissions tend to fall under scope 3, and it's the hardest to measure. So Microsoft, as an example, they have published what they define as scope 1, scope 2, and scope 3 from an emissions perspective. And you will find there that the vast majority of what they see as their scope 3 emissions fall under like the purchase of goods and services, things like capital goods, business travel can be a contributor, employees commuting in and out of data centers or in order to supply that service. And they are investing quite heavily to create what they call as a data lake, where a lot of the providers can contribute data to allow them to accurately publish and measure their emissions in this area. So what does it really mean when CSPs say they run on 100% renewable energy? So legally, all the cloud providers need to purchase or acquire what is known as RECs, renewable energy certificates, or in the EU, they are commonly known as guarantee of origin. So so these are the two standard certificates that a company claiming to be running on renewable energy need to acquire and hold in order to say they are running on renewable energy. So what are they? Essentially, power plants that generate electricity through renewables, wind or solar mainly. For every megawatt hour that they produce and supply to the grid, they get given what is known as RECs, renewable energy certificate. And those RECs are then put on the market and sold to other businesses. And the claim is, if you buy those RECs, then indirectly you've contributed towards using renewable energy, which is known as, I guess, offsetting. So you're offsetting your actual consumption from the grid by buying those RECs and contributing money towards helping invest in renewable energy. However, the issue is that a lot of these RECs are actually very cheap on the market, and they're in oversupply, and therefore the power plants do not really generate enough revenue from selling them to actually invest back in generating new electricity, which is what is known commonly as greenwashing. So businesses that claim that they're running 100% renewable energy and not doing anything else, it doesn't really contribute much to adding new green energy. So that's why a lot of the cloud providers actually purchase power purchase agreements, which is another concept that is known out there in the market. And I've got two examples here from AWS and Google, but Microsoft do exactly the same. And essentially, as a power what they do, they invest heavily in long-term contracts to build new renewable energy projects. So they invest to build like a large wind farm or a large solar farm, and the energy produced from those projects, they sell into the grid locally, and then they buy RECs, renewable energy certificates, back and consume the energy from the grid. So AWS, as an example, on their website, as of the end of 2021, they've invested in 274 renewable energy projects. Google have published maps, as well as AWS actually, of where all of the renewable projects are currently. And you will find that a lot of those renewable projects tend to be either in the US or in Europe. There are some in Asia Pacific as well, but they tend to be concentrated between the US and Europe. And that brings us to a third concept that we found, which is carbon intensity. So depending on the region that you select to host your workload on any of the cloud providers, whether it's AWS or Microsoft or GCP, where the region is located, there is more likelihood that the energy that supplies that region will be coming from green energy if it's in areas where they've invested heavily in projects, whilst in other regions or other areas of the world where access to such projects is not available, or access to clean source of energy is not supplied within the grid, then the carbon intensity or the amount of fossil fuel that involves in powering up the data center tend to be higher as a percentage. And actually, AWS, as an example, I think only last week or 2 weeks ago, have published all the data centers that power within AWS that are 95% powered by renewable energy, and the vast majority of them are based in Europe or in the US. I think around 20. I think in total about 20 data centers. If you're interested, there is an app out there called electricitymaps.com, which gives you live data in which parts of the world is consuming electricity that is predominantly green versus fossil fuel based today. And it's live. So this snapshot was taken 2 days ago. It would be completely different now, depending on the time of day and obviously the weather outside. My final point on another concept to bear in mind is power usage effectiveness. And that is the industry standard to measuring how effective data centers are being run. And essentially, it's the ratio between how much of the energy consumed within a data center powers the compute services that is delivered to host workloads versus power that is consumed in cooling and in power conversion. And the lower that ratio is, the more efficient the data center the more efficient the data center is. And currently the industry standard is around 1.57. And it's been dropping since 2007 all the way to last year. And the fact is, a lot of, all three cloud providers have published figures, PUE figures, to show that they are running below the industry standard. So Google have published that their data centers is at 1.1 PUE, which is very, very efficient. There's hardly any power that goes to waste or goes towards cooling and power conversion. And the vast majority of the energy they consume is there to power their servers. So I'll hand over to Ollie to talk about benefits of economies of scale.
Thanks very much, Mo. So what we're going to talk about here is really how the fact that all of the cloud service providers are operating at what we call hyperscale, and how as consumers of that we can take advantage of all the investments that they're making. So if we move on to the next slide, Mo. So the first thing to think about, want to go back, so Mo was talking there just about the PUE and sort of that efficiency of energy usage. And we've got here, Mo mentioned how the cloud service providers are operating at a lower level than you would do in your traditional data center. And the reason that they can do that is because they are running at a large scale. So they have less wasted utilization on the servers that they're running. So whereas in our traditional data centers, we might be running at an ideal situation of maybe up to 50% utilization, in the cloud environments, we're running at up to sort of 90-95% utilization, because these servers are being used by multiple customers. It's very much that sort of multiple using the economies of scale to put more and more workloads into the same infrastructure. And what does that really mean? Well, it means that looking at an example from AWS, with with their customers, they can achieve up to 77% fewer servers, which is 84% less power, and because of the way that AWS are sourcing their energy, as Mo was talking about earlier, that can be a 28% cleaner power mix, which all leads into up to 88% reduction in carbon emissions. So it's a real sort of takes home the fact that you can, by moving into cloud, immediately get returns. So now if we move on to looking at some of the other activities that the service providers have been able to achieve. So this is really thinking about the lifespan of hardware. Now, because all the service providers are becoming more and more efficient in their usage, they're actually able to get a longer life out of their servers themselves. So, for example, Microsoft now are extending their servers by an extra 2 years, so from a 4-year life cycle to a 6-year. Amazon are extending by an extra year as well on their hardware. And what that really means is that these assets are spending longer time in the data center, which means that the cycle from when new hardware is being built and then replaced takes longer. So you're actually getting a longer period without all the additional carbon that's being produced when new servers are being made. If we move on, please, Mo. So they're also looking at the cooling aspects, and cooling can be a very expensive part of operating a cloud data center or any data center. If you were running a traditional data center with lots of air conditioning, that can be over 40% of your total energy usage. But all of the vendors are looking to reduce that amount of dependency on air conditioning and are looking at things like cooling through water. So AWS are using a special evaporative cooling approach, and that's helping reduce the amount of water that they use, and therefore putting less contaminated water back into the water table. And Microsoft have been investigating, and they've been running a really interesting project of putting the data center actually into the ocean, and that doesn't have any cooling in that data center. It's being cooled by the ocean itself, and that's proved to be a very, very, very successful project. I think they're going to be running in the future, and it's out in Scotland's Orkney Islands, and have a look at it. It's very interesting. Next slide, please. So what are the other things that they're looking at? So thinking wider than just sort of energy, as you know, the components that go into a server have a lot of precious metals in, and some of those are toxic, like lead, mercury, and cadmium. So Microsoft's been investigating, looking at removing those metals out of the servers themselves, and I think we'll continue to see more progress there. So that means that you'll have less mining of precious metals, but also the impact that they have from a toxicity perspective into the environment will reduce. They've also been doing some great experiments looking at actually placing the motherboards directly into fluid to cool them. So fluid is much more efficient at cooling than air is. The fluid they use is dielectric, which means that it doesn't conduct electricity, which is definitely a key thing. And because they're storing the motherboards vertically, and the cooling efficiency of the liquid is greater than air, they can compress them in and have more motherboards in a smaller area, which ultimately will lead to smaller data centers. The other thing that they've discovered as part of this experiment is that the motherboards, the components themselves are more efficient and more stable. So they're able to run, they're getting an 80% improvement in reliability, which could then lend itself to running them for a longer period of time, and therefore reducing overall impact from an environment perspective. The carbon aware Kubernetes is looking at taking advantage of the different carbon footprints that the different regions have, and actually spanning your Kubernetes cluster across multiple regions, and intelligently looking to use whatever region's got the lowest impact on a particular day. And then the final piece that they're looking at is actually how they can take the heat that's produced out of a data center and use it to power homes. Now, you might have seen something similar in New York when you see the steam coming out of the pavements. Similar in concept, but it's certainly something that could provide useful advantage as we go on. We move on to the next slide, please, Mo. So the final bit on just the economies of scale is really around looking at some of the future projects that are taking place. And these are all around either reducing sort of immediate impact to the environment, or about increasing efficiency to such a great level that you need to use less energy to run them. So Project Cirrus is about replacing traditional electric switches with optical-based switching. The benefits of these are that they are 90% faster and use 66% less power. And if you think of all the switching that takes place, that's in those massive hyperscale data centers, there's great opportunity there. The Project Zurix is all about creating a net zero carbon impact when producing those motherboards and components, and looking at using biodegradable plastics, sustainable printed circuit boards, and bioconcrete materials as well for the data center. And Project Palix is about looking and using DNA to store data, and it's extremely dense, so you could store up to an exabyte of data on a cubic millimeter of data, and it also lasts for a very long time, a lot longer than we would really need to worry about, but it's got a half-life of over 500 years. So we just move on to the next slide now, and I think we've got a poll.
Yeah. So I have another poll just to engage everybody. So in terms of cloud adoption, where are you on the journey of cloud adoption today? So if you can answer this question, that would be great. Okay, thanks. So I guess the vast majority of you have answered, 43% have answered that you have mature cloud operating model today, which is great. So hopefully the stuff that we're talking about is not new to you. Some of you, 21%, have migrated heavy production workloads, but still not fully utilizing cloud native services. And in that we mean serverless architecture or native services to the cloud providers. And others have responded that they are in the process of migrating. So we've got quite a mix here, which is great.
Okay, thanks, Mo. Some interesting results there. And I think some of the what we're going to talk about now, for certainly those who are already in the cloud, could be of interest. So what we've taken here about the compute choices. So there are, as you know, there's many different services and many different ways that you can architect your solutions when it goes into the cloud. I'm going to talk about a few of those now. So if we move on to the next slide, please, Mo. So the first thing I want to talk about is changing the processor type that you're using in your VMs. So AMD processors are available in both AWS and they've done a study to compare them against the Intel servers, and they did a 12,000 VM study, and what they found was that the AMD processors are more efficient, and as a result, you need fewer of them to process the same amount of information and data. And the key thing I want to take away from here is that we had a 32% reduction in energy consumption, which ultimately saved 70 metric tons of CO2. So moving to an AMD processor is a very straightforward change. You can all it really means is choosing a different class of VM to run on, and you don't need to make any other changes to your applications to implement it. If we move on to the next slide. So here we're thinking about different types of ways of deploying your application. So we're looking at containers and serverless architectures. So containers are great because they allow you to really streamline what all the different components that you need specifically from to run your application. So if you think of comparing a container to a virtual machine that's running an operating system and all of the other bits of software that are needed to make that virtual machine operable, then compare it to a container that you will only have the bits of software that need to run that specific application. It means that the container itself is far more efficient. Then if you think about the fact that you can run multiple containers on a smaller number of hosts, which we call workload density, you can have a really high workload density and really work that host and be more efficient. So what that means is that you are able to run more activity, higher workloads on the same number of hosts that you would have done previously by adopting containers. The second aspect is thinking about event-driven serverless. So if you want to just quickly slide back, Mo. So this is where you're only using the compute power when you're actually executing the transaction, the application is running. This can and then all of that compute power is then available for the other customers that are using it. So that it means that you're highly efficient when it comes to using the servers themselves, so they're fully utilized, and you can achieve between 70 and 90% of efficiency and savings by moving to a serverless architecture. Let's move on to the final piece, mode, which is all about changing the processor type. So, traditional AMD and Intel processors are running an x86 chipset, which is you'll all be familiar with from your Windows laptops or computers. But we're seeing more and more ARM processors coming into the cloud environment. So an ARM processor is running a reduced instruction set, which means that by definition is going to be faster and more efficient at executing the transactions or your applications, the calculations. There are AWS have got their own Graviton chip, and then Microsoft and Google are both using the Ampere Ultra chips. When it comes to the sort of savings that you can be looking at, it's anywhere between 60 and 65% energy savings that you could achieve. Now, the thing to bear in mind with moving to an ARM, reduced instruction set processor, is that there will be some differences. Now, any applications that you've written using a scripted language, such as Python, should run without any changes or at least minimal changes. Other simple applications would need some recompiling to essentially run on the new chipset, whereas any sort of really complex applications that have a lot of dependencies within each other will probably require further development work, maybe a little bit of refactoring before they can be run on this new processor, but definitely worth looking into. So I think if we move on now, we're going to hand over to Danny.
Cheers, Ollie. Thank you. Yeah, won't take too long on this one, but yeah, just wanted to give you an idea of a sort of a real life case study and something we've been involved in for the last couple of years. So probably don't need to explain what who NHS Test and Trace is, but we've been involved in that from a cloud point of view for since summer of 2020, and we were kind of one of the organisations responsible really for hosting a whole load of the sort of second wave of COVID applications after this sort of initial rollout of a kind of a whole plethora of services. We kind of brought them together in Test and Trace across all three clouds. And one of the things, obviously, we're incredibly obsessed with is cost. Of course, it's a huge beast and requires a lot of cost optimization. But we realize cost, desire and need to be able to stand up when we're questioned around sustainability and what the platform means, you know, in terms of what is the impact of the Test and Trace platform in terms of emissions, etc. So we rapidly looked at a couple of options here, and I'm putting these two. They're both Microsoft focused, and I'll come back to the reason really why in a moment that I want to kind of highlight these. Now, Mo already mentioned Microsoft Cloud for Sustainability. Just for the record, the name is incredibly misleading. It's not another cloud. It's not another platform. It's not something else. It's just effectively branding. Actually, under the hood, it runs on Dynamics 365. The idea is that the name of it is kind of all encompassing, and as Mo mentioned before, it does cover lots and lots of different things really. So the idea here is that it provides you with the ability for any organization, whether they're running Azure or Microsoft workload or not, to be able to start to collect data around their organization. So this may be an organization who's entirely on-prem, and the idea is that for the different scopes, you can actually start to input data. So if you've got data on, for example, the business travel in your organization, or the employee commuting, or if you've got data around your electricity providers and what they give you, effectively there is a data model behind here, and the data model allows you to input as much information as you can provide, like I say, on the different scopes. The quite nice thing about this is it is entirely really up to you. It could be useful for a very small organization, or it could be actually really useful for a multinational. It understands regions. It understands obviously that you're going to have, for example, an organization, say manufacturing, may have offices. It may globally, it might have factories, and of course you can input information and slice and dice this. But importantly, it gives you a baseline view and something you can grow on, and of course then you can try and start to track your progress. So we found this really useful. It's a big thing, and for any enterprise, this could take a long time, given the amount of offices, the amount of staff, the amount of different scopes that you can actually collect. But it's truly powerful. I bring it up here because it's free for 30 days. In fact, you can get it for free for 60 days and maybe longer. And you would absolutely need that if you're going to do it for any enterprise organization. But even though the name says Microsoft, effectively treat it like an ISV product. It might be something that you want to explore as a way of just starting to collate your information on your enterprise. But we certainly found it useful. And then the on the right hand side, there is two emissions dashboards, which I think are relatively well known now. So one covers Azure and one covers Microsoft 365. So both two of sort of Microsoft clouds, if you like. Now the idea here is that we can very quickly provision it. Both of these are free, incidentally. And again, if you've got Power BI instance in your organization, which you could essentially host for free as well, so as long as you've got a tenant, you could actually stand this up for free. But the idea here is that you fire them up, you give it your Azure credentials in terms of some details about your tenant, and then very quickly it will start to pull down information about either Azure or M365, predominantly your Office in the cloud data. Now we found this especially interesting because while we're obsessed about costs, it was very interesting to see the correlation between costs and carbon emissions. Also, we were on a real objective to try and manage our joiners, movers, leavers. So we don't have we want to get, we want to be as efficient as possible. And one of the things you can see on the top right, I mean, it's not super big in the image, but there is a correlation between us offboarding users efficiently. So these are users who are using Office 365, Microsoft 365 services that are dormant. They have a carbon footprint. There is a carbon footprint by just them being on the platform. And what we're able to show is by having an automated offboarding process, which identifies users who are no longer using the system, we could actually reduce our carbon footprint. And you can see here down to it's actually this is a little bit old, this data, but 211 grams of carbon per year per user. And this is significantly down, but it is a proper correlation between having proper processes in your organization and actually driving that efficiency. And we see the same on the diagram on the bottom right, which is the Azure consumption. We could see the Azure emissions, so we could see the impact. And the great thing about the emission dashboard is that obviously Microsoft know that the racks effectively and there's different generations even in the same region of different efficiencies, so they can provide all of that data behind the scenes, which gives us really a very good view of the emissions. And you can see here we've got a nice downward curve. Just finally on this, I just want to call out the title actually about migration sequencing. What we see is that we now we're talking to other customers where they're using tooling like this and information like this to drive the conversation about the sentencing of applications. So when they're moving on-prem into cloud, or when they're maybe doing modernization in the cloud, maybe moving from IaaS to PaaS, they're looking at sustainability as part of that sentencing and deciding maybe some of the workloads that may not be the most obvious ones actually have a much more impact on sustainability, and they're being fronted or being performed first. So it's kind of changing the conversation. And very finally, like I say, all of this is essentially free. The stuff on the right, you would have to have something in Microsoft Estate to take advantage of it. On the left, Microsoft Sustainability, you don't need to have anything in Microsoft Space to take advantage of that. And that's me. I'll hand back to Mo, I think, for another poll.
Thanks. So we have the third and final poll for today, and the question is around your modernization capability. So do you have, I guess, skills in-house to modernize your applications, to take more advantage of cloud-native architectures and modernize your application to be more sustainable? Okay, thanks for all your responses. So the majority of you have quite a strong development team in-house, which is great. So 55% responded with that. So hopefully you can take advantage of what the cloud providers offer. Some of you are still building up your team and capability in-house, and others predominantly use COTS or SaaS off-the-shelf products, and therefore don't have the in-house development team today. So I'll hand over to Sam to just talk about our sustainability service line.
I think we're actually going to Carl, but this is just to position, I guess, beyond some of the cloud opportunities, other real opportunities in the world of using tech and getting value from tech in a sustainability context.
Yeah, thank you. Thanks, Sam. And obviously, cloud is one part of the picture and an important part. A huge amount of our stuff potentially runs in the cloud, but we have to think about optimizing the footprint of the whole of the software that we build, and obviously the hardware we build. I think somebody mentioned in embedded carbon or embodied carbon in the chat, and the fact that the cost of actually building the hardware, deploying it, moving it, recycling it is potentially even bigger than the energy use of that hardware over its lifetime as well. So it's really important to consider all that stuff. And to look at one of my passion areas is green software development, and how we can develop software more green by thinking in the right way, building in culture, but also looking at our software delivery process and seeing where we can inject type activities and ways of thinking into there. For example, including carbon in non-functional requirements and needs, balancing carbon against other non-functionals, so you can determine whether you really need those 4 nines of availability, or actually you might use a different pattern for high availability that enables you to reduce the carbon footprint overall. True lean thinking to how we develop our requirements and architectures, making architectural decisions which purposely minimize the footprint so we don't have to back out of them later. And you know, I really believe in measuring, learning and improving, but also you can learn how to do it right first time or do it better first time. And general efficiency lens to development over potentially velocity in some cases, and applying that to quality process. The picture here is just one of the questions when I talk to people about this is generally, where do I start? There's lots, I've got a whole hour-and-a-half talk on this. I'm sure I'll give it at some point. And there's a big question about where do I actually start? Well, some of the things you can do is just that initial organization-wide education about all the different concepts behind carbon use in software. You can look at using carbon ops monitoring like we've seen here for Danny's just described to us for Azure. Maybe even application baselining all the way from high level, short software carbon accountancy down to really detailed something like the software carbon, the SCI specification by the Green Software Foundation, and then building like a hit list of things you can go after and how they might improve, and just working through that all the way through to embedding that in your culture, making sure you're doing it right first time. Even governance, like architectural governance. If you're putting NFRs and you're doing as part of your key design decisions, sustainability or green credentials in that, can you bring that into your architectural governance boards and actually encourage people to properly think about the different options? And then finally, technology driven sustainable business practices. Once you've got all that in place, how do I actually use technology to change my business practices so my business is more green as a whole? I was just going to touch on that brief now. If you're interested, if you head over to the BJSS website and over to our engineering insights, there's a whole long article about our guide to green software development. Check it out. Thanks. Sam.
I think lesson learned here that we've tried to impart a lot of information in a fairly short space of time, so I won't keep us from any QA too long. What this is showing is that as well as some of the more focused technical opportunities, we've also done a lot of thinking around how to drive sustainability improvements across a product life cycle, going through stages such as through like design, development, distribution, and onto the services angle. And we've looked at this through those 6 areas that we've called out, which play to our advisory expertise and the things that we have great expertise in doing. We take a traditional opportunity identification lifecycle in terms of that strategy and vision, identifying opportunities to deliver improvements, running proof of values, and then scaling and embedding those solutions and leaving you in a place in your organization where you can continue to improve on those delivered solutions. I guess the only thing that I would like to say is that we feel that this is, as well as using kind of typical areas people are used to in terms of thinking about how to optimize processes and typical process optimization, how to be data-led in decision-making, the importance of agility. This is another area that probably accelerates that trend. We're also looking at some of the net new things in terms of how end user devices, applications, websites consume energy, at what times they do that, and how we can influence that, as one example. I would probably pause there. Anything else I should call out? Also things like streamlining architectures, processes and services. And I think the other thing that we're looking at is how we can use design thinking to kind of for behavioral nudge theories, and how we can start to influence the decisions that our consumers make in using our services. And finally, the other thing that applies across this is having the right kind of KPI suites in place, building observability suites and using available data to kind of drive decision models, all of these things that we're thinking about, but we're doing that in a real agile context, recognizing that there's a huge scope of opportunities here. There's challenges in building a baseline, and actually some of these data information challenges shouldn't stop you from starting to address your scope and 1, 2 emissions, and to reduce that footprint.
Okay, well, thanks a lot for your time today. We hope that you found the information we shared today useful. I think in general, there is a lot of learning to be had across the industry in this space. There is still a lot of missing points and understanding of the available data that out there that we can consume. So there is a journey that we're going on together. So if you're interested in having any follow-up discussions, please do reach out to us. We will follow up this webinar with an email that provides more information about our sustainability offering. And we hope to hear from you soon. So thank you very much.